All right, so the second method, we would need this because when we switch the x and y, that's the first step, is to actually find the inverse. So we get x equals y cubed minus 4y squared plus 7y minus 1. It would be impossible to solve for y by itself like we did in method 1. And so in this example, we're actually going to find the derivative from this step. And so we're going to have to use implicit differentiation to find the derivative. So the derivative of x is 1. Y cubed would be 3y squared dy dx minus 8y dy dx plus 7 dy dx. And then minus 1 becomes 0, so we don't even need to write that. So we're going to factor out dy dx. So it's 3y squared minus 8y plus 7, and it's equal to 1. So we get dy dx equals 1 over 3y squared minus 8y plus 7. So then so that was step B and C. So we did step B. This right here was step C. Step D says to replace the k value. So it says when x equals 1. And so we have to find what the y value is when x equals 1. So we're going to have to come off to the side and do some calculator work. So we're going to set 1 equal to y cubed minus 4y squared plus 7y minus 1. So then on your calculator, you can find this. You can set the right equation equal to 1 and just see where they intersect, or you can subtract the 1 over and find the zeros. But either way, you should be able to do that and get y equals 0.349371. So once you do that, the last step, E, would be to plug that number in for your y. So y equals the 0.349. Once you plug that in, you should get 0.21876. And so that's finding the derivative of an inverse using implicit differentiation.